Welcome to Fiber Optics 101 presented by Hitachi Cable America. Over 500,000 miles of fiber optic cable has been installed over land and on the seafloor to link countries around the globe. Without fiber optic cables, the Internet as we know it would not exist. So, what is fiber optic cable? Fiber optic cables typically consist of multiple fiber optic strands of glass over which encoded light signals are transmitted. This image depicts the layers of a strand of optical glass. The strand consists of a solid glass core, which is surrounded by a layer called the cladding. The cladding layer helps keep the light within the glass strand. An outer protective acrylate coating is applied for durability. The outside diameter of a fiber optic strand is generally about 250 microns. In this state, it is called loose tube. A human hair is about 100 microns. For added durability and to make terminations easier, an additional layer called a tight buffer is often added. This tight buffer layer increases the diameter of the strand to 900 microns. There are two primary types of fiber optic glass available. Single mode, with a core of about 9 micron, is designed for long-distance applications and requires lasers as the light source. The other is multi-mode, which is designed for shorter distances. Multi-mode glass is available in both 62.5 and 50 micron. 50 micron, the newer type, is designed for faster network speeds such as gigabit and 10 gigabit Ethernet. Slower applications for multi-mode glass utilize LEDs as the light source. Faster applications such as gigabit and 10 gigabit use an inexpensive laser called VCSEL, which stands for Vertical Cavity Surface Emitting Laser. There are only a handful of companies in the world that manufacture fiber optic glass. Corning, having invented fiber optic glass, is the oldest and largest manufacturer. Corning optical glass is the standard glass used in all Hitachi Cable America fiber optic cables. Fiber optic links shorter than 550 meters, such as within a building or in a campus environment, typically use multi-mode fiber optic glass. This is because of the combination of the electronics used and the design of the fiber optic glass limit the distance that signals can travel before they degrade. Longer runs, such as links to a municipal network or in a larger campus environment, will utilize single-mode fiber optic glass. Single-mode glass can function up to 40,000 meters without the use of electronic repeaters. Single-mode applications utilize lasers that transmit light down a single path of the glass strand, thus their name single-mode. Glass quality is extremely important for optimum performance in the reach of the link. The image on this page is of an indoor interlock armored cable with tight buffered glass strands. This cable can be plenum or riser rated. Hitachi Cable America also has a plenum rated indoor-outdoor version of this cable. In this cable, tight buffered glass strands are used to allow easier termination and handling. The aluminum interlock armor protects the inner cable and fiber optic strands during and post-installation. There are many different constructions of fiber optic cables to accommodate a variety of physical environments. There are indoor, indoor-outdoor, and outside or OSP constructions. Today, you can get many different cable constructions with either tight buffered strands or loose tube strands. Most applications that utilize fiber optic cable require a pair of strands to operate. One strand accommodates the signals being sent, while another strand handles the signals being received. When installing a fiber optic cable, it is best to install a cable that has more strands than you originally need. This offers redundant strands and allows for future growth. Fiber optic strands are also typically installed in even numbers, with 6, 12, and 24 strands being the most popular. In a typical network, media converters are an inexpensive way to extend the network to locations that copper category cables can't reach. A converter at each end consistently converts electrons from the copper network into photons for the fiber link and back again. Switch-based fiber modules are also popular for larger fiber networks. Electronics that provide data rates of up to 100 gigabits per second over fiber optic cables are currently available. Quiz time. Number 1. What is the name of the centermost part of a fiber optic glass strand? Number 2. Single-mode fiber is perfect for very short lengths. True or false? Number 3. 50-micron multimode fiber will support 10 gigabit Ethernet. True or false? Number 4. Type-buffered fiber strands help reduce the weight of the cable. True or false? Number 5. What manufacturer invented fiber optic glass? Number 6. LEDs and VCSELs are ideal for single-mode glass. True or false? Number 7. Fiber optic cables are great for power over Ethernet because they can accommodate 100 watts of power. True or false? Number 8. Loose tube cable designs use fiber optic glass that are 600 microns in diameter. True or false? Number 9. Maximum distance for multimode fiber is about 550 meters. True or false? Number 10. Media converters are necessary when going from a copper-based network to a fiber-based one. True or false?